what you see in the picture is the cross-section view of a circuit breaker. In this video we'll understand exactly how the circuit breaker works and how the tripping mechanism cuts off the supply in case of fault current or faulty circuit. So the red wire, what you see is the supply. Let's say the current comes and then it's with the help of the screw bolted to this terminal of the circuit breaker, and here it goes, and this is a bimetallic strip, and here is the spring loaded arm, and here is the linkages. So this is a link, here is a link, and then this is the conductor. The current comes through this blue wire and then it goes to the bimetallic strip, and here you can see behind there's one more conductor or any metal piece which goes to this link, and here whenever the circuit breaker is on, this will go and hit or make a contact here, thus the current supply is taken out through this terminal. So this is the input terminal and this is the output terminal or outlet, simply we can say in layman's term. So now let's see what happens when it is working, alright, so these contacts are open now, the breaker is in off position, now it's on, the current starts to flow through the supply line, that's the red line, the current flows through this terminal, and here you have screwed it, so remember that it flows through this. If it's loose, then definitely there's going to be a problem with the circuit breaker, like arcing, or even the circuit breaker might trip. Any fault may occur over here. So through this it goes to this and enters the bimetallic strip. So as the current flows, the bimetallic strip gets heated up. So let's say the circuit breaker is rated for 20 amps. Till 20 amps nothing will happen to the bimetallic strip. Of course it will expand, but the expansion will be within the limit, it will not trip the operating links. However, let's say if the circuit breaker or the bimetallic strip is heated up more than 20 amps, let's say 40 amps or 50 amps depending on the overload or the thermal expansion setting. Let's say for example 40 amps, what happens is this expands and then the link is taken or pulled back so that the contact is open, no more current supply passes through. So now the current flows through this link and through this wire, through this contact, goes to the output terminal. Now let's see what happens when the overload gets. So this is how it works. I'll show it once again. So the current flows, it starts to expand, and as it expands, if it's above the limit, this is sliding down, thus releasing this link, and then the link is open due to the spring. The spring pulls it back. Let's watch it once again. You can see it's coming back, this link is released, and thus this is being pulled back and the contacts are open now. Now the breaker is in trip position. After it's tripping, it's in a center position. On is towards this, off is this, and when it's in center position, it's in a trip position. You got to reset it, and resetting depends upon the time the bimetallic strip comes to normal position. It has to bend back. When the current flows through it, the bimetallic strip gets heated up. When the supply is interrupted, the bimetallic strip cools down and comes back to its original position, and thus it cools down, allowing you to put off the breaker and reset it. Let's see now what happens. So after the bimetallic strip cools down and comes back to its original position, you will be able to reset the circuit breaker from the trip position. As I said earlier, on position is towards like this, which I have shown in the arrow mark. Off position is this, and the center position will be the tripped condition. And now I have pulled this lever back to let's say I'll show you once again. Now it's in off position and the contacts are open. Now you can rectify the fault and put it on, so that again the circuit is connected and the supply flows through. So this is how a circuit breaker works basically.
Hello friends, my name is Bhupendra and I am going to explain circuit breakers. In this video, we will explain introduction to circuit breaker, basic definition of circuit breaker, working principle and types of circuit breakers. So friends, the modern power system deals with huge power network and huge numbers of associated electrical equipments. During short circuit fault or any other types of electrical fault, these equipments as well as the power network suffer a high stress of fault current in them, which may damage the equipment and networks permanently. For saving these equipments and the power networks, the fault current should be cleared from the system as quickly as possible. You can see a miniature circuit breaker in the diagram. So we can define the circuit breaker as a circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to detect a fault condition and by interrupting continuity to continually to immediately discontinue electrical flow. You can see in the diagram there is a spring and a circuit breaker can be consist of two contacts. So there is a first is fixed contact and another one is moving contact. Also there is a coil and there is a pivot. So as soon as the coil is energized, the fixed and moving contacts move themselves apart. So moving contact will move apart from the fixed contact. In the working principle, the circuit breaker mainly consists of fixed contact and moving contact. In normal on condition of circuit breaker, these two contacts are physically connected to each other due to applied mechanical pressure on the moving contacts. The potential energy can be stored in the circuit breaker by different ways, like by deforming metal spring, by compressed air or by hydraulic pressure. In the previous diagram you see the metal spring, but whatever the source of potential energy, it must be released during operation. Release of potential energy makes sliding of the moving contact at extremely fast manner. So there can be any operation can be there depending of the arc quenching medium. So as soon as the fixed and moving contacts move apart, there is a arc. So as soon as the arc produced, we have to quench this arc, we have to extinguish this arc.
Assalamualaikum, and so today I would like to talk about advantage and disadvantage of circuit breaker. Okay, first, as you see here, advantage of circuit breaker: free from arc and fire hazard. Second, low cost for maintenance and simple mechanism. Third, low arcing time and high contact life. And fourth, silent and less vibration operation. 5. Due to vacuum, contact remain free from corrosions. And last, no byproduct form. Okay, disadvantage: high initial cost due to creation of vacuum. Surface of contact are depleted due to metal vapor. High cost and size required for high voltage breaker.